Okay, conic sections. Right, now these are formed when a circular cone is intersected by a plane. Okay, so have a look at this. If we intersect this cone like this, we'll produce a parabola. Right through the middle of it, like this, we're going to produce a circle. Okay, at an angle like this, we'll produce an ellipse. And if we cut it like this, we'll end up with two parts that form a hyperbola. Okay? Right, parabolas. Now these are graphs of the quadratic function. Okay? Now if we state it here, sounds a bit of a mouthful, but look, a parabola is the set of all points in a plane equidistant from a fixed line, which we call the directrix. Get to learn that name. And a fixed point not on the line, the focus. Okay, well here it is. So here is, let's get another arrow up. Here's a parabola. Okay? We have the minimum point here, which is the vertex. Okay, here's the vertex. Now, the distance to the focus point here is the same as the distance to the directrix line. Okay, so remember that when we're going to be graphing these and getting all the information together. Okay, so again, distance to the focus, same as vertex to the directrix. Okay, now what this means here, okay, in this box, is this. Equidistant. Right, if I draw a line from the focus to the parabola, it's the same distance as the parabola down to the directrix. Okay, if I do another one, if I do straight lines up here, same distance from there to there that it is from there to there. Okay, now then, the line that's perpendicular to the directrix and contains the focus is the axis of symmetry. Okay, well, we've seen that before with parabolas. Okay, the axis of symmetry. A bit like, remember, reflecting error over the y-axis, but this could be anywhere. So we have the axis of symmetry, we have the focus, we've got the vertex and directrix. Okay, so we might be looking for all these pieces of information. Now, I'm not going to derive the standard equation of the parabola, okay, but we're looking at the vertex at 0, 0, okay, right here, right on the origin of the xy axis for now. But we get, if you look at this, do all this, here is the standard form of the equation of a parabola. Okay, now this one applies to this, okay, because we'll see over here, here we go, x squared equals 4py. But we also have y squared equals 4px. Now how I distinguish between the two, x squared equals 4py, this is opening up or down the y-axis. I think of it like that. It opens up the y-axis or it goes down the y-axis, opening up, okay? And that's the letter at the end, all right? So if you look at this one, okay, can you see this is opening along the x-axis, okay, that way or that way. So this is the x at the end. Again, y at the end if it looks like this or possibly like this. And x at the end if it looks like this or possibly like this. Okay, so try and remember which is which. Okay, again for these, vertex at 0, 0. Okay, let's have a look at an example. Here we go. X squared, if I think of x squared equals 4py. Okay, now can you see 4p is this negative 12 part. Okay, so if I divide by 4, I'll get the focus, okay, or at least the focus distance. So can you see if I divide negative 12 by 4, I'll get negative 3. So that's the focus distance, okay? Now think about it. Again, it's a y direction one, and it's negative, so it's going to go down the y-axis, negative y, okay? Again, think of it as negative y. Okay, so here we go. 1, 2, 3, down the y-axis. There's the focus. The point is 0, negative 3 as a coordinate, okay? Ordered pair. So if we go 3 down the y-axis to get to the focus, we'll go 3 up the y-axis from the vertex to get the directrix, and here it is. Now again, written as a proper equation, this is y equals 3, right? Okay, crosses through 3, but this is y equals 3. It's a line, not a point. Okay, what we're looking for, the focus and the directrix, then graph it. Okay, well there we go. Okay, now how you do this, graphing it, okay, we know that's there. Okay, so we know that's there. We put the focus in, we do the directrix, and to graph it, we basically just kind of do a swooping kind of line. If I do it like that, where that was positive 3 directrix, there was negative 3 down for the focus. Here's my axes, okay? So I've done a rough one there. But actually, there's also this to remember. The distance from the focus to the parabola, okay, is twice p, okay? So if p is 3, this will be 6. And can you see, look at that, 6. So this point here, if it's any help, is the point 6, -3. So if I go twice the focus distance this way, I'll end up at -6, -3. And that just helps me draw it. Okay, let's have a look at another one. Right, worded differently, we have vertex 0, 0 and focus 5, 0. Now think about it. 5, 0, that's 5 along the x-axis. It's going to be a y squared equals 4px type of parabola. Okay, that form. Okay, it's going along the x-axis and the positive direction. So if the focus is 5, 0, then we've multiplied it by 4. Here we go. We'll get the equation. There we go. I know it's y squared. Okay, it's going along the x-axis, so I'm going to have the x at the end here. Okay, again, remember it's going along the x-axis there. So x at the end, and then 4 times 5 is 20. That's the equation. How do we graph it? Again, 0, 0. We know the focus is at 5, 0. It tells us if we have to, we haven't done it, but if we have to put the directrix in, that's going to be at x equals -5. I'll write that down. X equals -5. Okay. Now again, remember this. Okay, I said the distance from the focus to these points, or another point to draw, is twice p, is 2p, twice the focus. Okay, so if the focus here is at 5, if we go up to 10, now of course it's not on here, not on the scale, but suppose I go up to there, that goes 10 up and 10 down. Okay, let's pretend it's there. Then this is what these should pass through. Okay, and that's me just drawing it a bit more accurately. Okay, so not exact there, but imagine that that is 10 up and 10 down because the focus distance was 5. Okay, and that just helps you graph it.